All right, hi everyone. We are going to take a look at the Unit 3 review so you are ready for your Unit 3 test. Remember that you have multiple attempts on this and you can actually use this review on your test. So all these little cheat sheets, you can use it on your test. The test is going to look very similar to the review. So hopefully you have success. Okay? So if you look at Unit 3.1, remember there was all these different angle pairs. Okay, that's all we learned about in 3.1. So if you take a look at here, there's going to be a question just like this on the test. And just like this on the test. You're just going to drag and drop. So if you remember, 8, 3, 7, and 4 are what we call our interior angles because they're in between the two lines. Whereas 1, 2, 6, and 5 are on the exterior because they're outside of the interior. They're in the exterior. So alternate exterior angles would be on alternate sides, opposite corners. So they wouldn't be 8, 3, 7, or 4 because that's in the interior. But the exterior would be 1, 2, 6, and 5. 1 and 5 are on opposite corners, just like 2 and 6. So for instance, 1 and 5 would be alternate exterior angles, just like 2 and 6. So you would just drag and drop. Alternate interior would be something like 8 and 4, 3 and 7. You see how those are on opposite corners, but they're in the interior. So 3 and 7, 8 and 4. Okay? So something like 3 and 7, 8 and 4. Okay? Same side interior has to be on the same side of the transversal. So if our transversal is L, in the interior, 3 and 4 are on the same side. They're both on the right side. 8 and 7, they're on the same side. They're both on the left side. So something like 7 and 8 would be same side interior. Same side exterior, same concept, but in the exterior. So like 2 and 5, 1 and 6. Okay? Corresponding angles are angles that are on different lines but the same position. Different lines, same position. So if you take a look at like this group of 4 right here, 1 is in the top left of this group of 4. Okay, look at down here. What's in the top left down here? Well, 7 is in the top left. So 7 and 1 are corresponding angles because they're both in the top left of their little group. Just like 2 and 4 are both in the top right. Those are corresponding angles. 3 and 5, 8 and 6. So like 1 and 7 would be an example of corresponding. You would obviously fill in the rest. Vertical angles are angles that are across from each other. So 2 and 3 are side by side, 1 and 2 are side by side, but 2 and 8 are across from each other, just like 1 and 3, 4 and 6, and 7 and 5. Okay, you would obviously fill out the rest. But guys, these are gimme points on the test. Okay, use this as a reference point if you need it. Again, this is also gimme points. We already went over this. 8, 3, 7, and 4 are in the interior. 8, 3, 7, and 4, which means the rest of them are in the exterior. These are easy, easy points, people. I'm telling you. Okay, that's all of 3.1. That's all it was. It was just identifying all those different angle pairs. Okay, 3.2. There is this cheat sheet that tells you everything you need to know. Remember, there's all these different angle pairs. There's 1, 2, 3, 4, 5, 6. Really remember 7 linear pairs. So there's 7 different angle pairs. And they're either supplementary, which means they add up to 180 degrees, the two angles, or they're congruent, which means you just set them equal to each other. Those are the only two options, people. That's really it. So if you can identify the type, just identify the property and you're good to go. Okay? So for instance, there's also a video. Okay, we're going to skip these couple. But on number 7, so if you look here, both of these angles are in the interior. Okay? They're in the interior. They're on opposite corners, so they're alternate interior angles. They're not on the same side of the transversal, so they're alternate interior angles, 92 and the question mark. So these alternate interior angles. And if you're like, oh man, Mr. Colston, I know they're alternate interior angles, but I don't know how to find the measure of the missing angle. I have no idea where to start. Well, on your test, you could literally have this review open and go back up here and say alternate interior angles. Well, those are congruent to each other. So I'm just going to set them equal to each other. So 92 equals this angle. So what's the measure of my missing angle? Well, just 92. So simple. These are equal to each other because they're alternate interior angles. Okay? What about here? Alternate exterior angles. If you're like, ah, man, Mr. Colston, how did you figure that out? Well, I could even go back up to this cheat sheet. Alternate exterior angles. They're both on the exterior on opposite corners. So this would be alternate exterior angles, which I also know that those are congruent to each other. So this would also be 69 degrees. Okay? And again, by the way, these problems may look different for yours because some of these are randomized, but hopefully it gives you a good sampling. Now here, these are what we call corresponding angles. They're both in the top right of their little pair. So these would be corresponding angles. These would be congruent angles. And if you forget that, remember your cheat sheet. Corresponding angles are congruent to each other. So I can set them equal to each other. So now here's where we got to do a little bit of math. Okay? So let's talk about what we would do here. 13x plus 9 would equal 2 plus 14x. So let's do that math. 13x plus 9 equals 2 plus 14x. Let me zoom in a little bit so it's less blurry. Okay. Now, so some people freak out and they're like, oh my goodness, there are x's on both sides. What am I supposed to do? Well, we either need to subtract 13x on both sides or subtract 14x on both sides. I like to do the thing that keeps things positive. Okay, so if I subtracted 14 on both sides, I would end up with a negative over here. I don't want that. I'm going to keep things positive. So I'm going to subtract 13x on both sides. You totally could have subtracted by 14 on both sides. It's no big deal, but I like this. So we'd have 9 equals 2. 14 minus 13 is just 1x. But I don't really like putting that 1 there, so I would just keep it as x. So now we have 9 equals 2 plus x. To get rid of the 2, I would subtract by 2 on both sides. 7 equals x. All right. So if you go back to your problem, let's bring that problem back over here. Our question was, after solving, I found that the value of x is, well, I found that it was 7. Okay. Congruent angles. So like if you take a look at this number 9, these are same side interior angles. They're both in the interior and they're on the same side of the transversals. So this would be a same side interior angle scenario. These two angles are what we call supplementary. And if you don't know why I know that, if you go back up to your cheat sheet, same side interior angles are always supplementary, which means they add up to 180. So if you take a look here, let's add these up to 180. So I would have, for instance, my two angles add up to 180. So I have x plus 89 plus 111 plus x equals 180. Now, some people are like, man, Mr. Colston, I don't know what to do here. Well, you're always going to combine like terms when possible. So if you take a look at all this stuff on the left, I have some x's. Those are like terms. I can combine those. I also have these numbers, 89, 111. I can combine those as well. These two x's would combine together to give me 2x. 89 plus 111 would combine together to give me 200. And I would keep going, equals 180. All right, now that doesn't look too bad. We would subtract by 200 on both sides. 2x equals negative 20. Divide by 2. X equals negative 10. Okay, so this is how we would solve it if it's a supplementary angle pair. Okay, like same side interior. Remember, same side interior and same side exterior and linear pairs are all supplementary. So here, since it said define x, we'd say x is -10. Cool. All right, here would be corresponding angles. We would set them equal to each other. Okay, let's keep going. So that is unit 3.1 and 3.2. Guys, it's really not too bad. You're either identifying the angle pairs, or you are adding them up to 180, or setting them equal to each other. Okay, it's really just a lot of algebra. Okay, now unit 3.3, we kind of talk about some other things. We can classify triangles based on sides and based on angles. Okay, scalene, isosceles, and equilateral are the way we classify sides. Scalene triangles have all three different lengths. None of the lengths are congruent. None of them are the same. Isosceles, you have two of them that are the same. In equilateral, they're all the same. Now, how do you know if they're the same visually? Well, if two sides have the same number of tick marks, so for instance here, all three sides have one tick mark, which means all three sides are congruent. They're the same length. Okay? Now down here, two sides have two tick marks, but they have the same number of tick marks. So if there's the same number of tick marks, it's the same length. So like an isosceles triangle would be like this. Now it doesn't matter if there's one tick mark or two, as long as there's the same number, they're equal. Okay? This would be sides. Now angles, acute triangles, all three angles are acute, so they're less than 90. They're little cute little angles. If you look here, all of these angles are less than 90 degrees. A right triangle, on the other hand, has this right angle. It's a 90-degree angle. It has that right angle. It just has one, because if it had more than one, it wouldn't be a triangle anymore. And an obtuse triangle has one angle that's actually bigger than 90 degrees. So like this is 120 degrees. Okay? That would be an obtuse triangle. It can't have more than one of those, just like a right angle. It can't have more than one of those. An equiangular triangle is the same thing as an equilateral triangle because all of the angles are 60 degrees. They're all the same angle. 60 plus 60 plus 60 is 180. Okay? That would be an equiangular triangle. So a hint for you, anytime you have an equilateral triangle, you'll also have an equiangular triangle. But anytime you have an equiangular triangle, you'll also have an acute triangle, which means that all my angles are acute. Because by definition, an equiangular triangle, all of them are 60, which is less than 90. Okay, so let's get into it. If you look at this triangle, we have some tick marks here. We have two tick marks. We have a tick mark here and a tick mark here. So that means that this side is congruent to this side. This side is congruent to this side. But that's all we know. We don't know anything about this side, but we have two congruent sides. So if we look back up here, two congruent sides means it's an isosceles triangle. Okay? Is it equilateral? No. Is it equiangular? No. We only have two angles that are equal to each other. Scalene? No. What about this one? We have a triangle that has one tick mark here, two tick marks here, and no tick marks over here. So none of the sides have the same number of tick marks. Well, that means that they're all different then. So all sides have different lengths. That means it's a scalene triangle. Not too bad. What about this one? All of our sides have one tick mark, and all of our angles seem to be equal. So this means that our angles are equal, equiangular, and our sides are equal, equilateral. And remember, that's always going to be true. Any equilateral triangle is also going to be an equiangular triangle. Okay, kind of a hint there. What about 15? Well, man, we have an obtuse angle right here. So this would be an obtuse triangle. If we have one angle that is obtuse, it means it's an obtuse triangle. Okay. That would get rid of our angle measurements. But what about by line? So If you see here, we have one side with 2 tick marks, one side with 1, and one side with none of them. So this is kind of like this one. This was a scalene triangle. None of our sides are the same. Cool. This is an obtuse scalene triangle. What about this one? Well, we have a right triangle because it's a right angle. We have a right triangle because there's a right angle. And 2 of our sides are congruent, so we have an isosceles triangle. This would be called a right isosceles triangle. Cool. So guys, if you're struggling with this, just look up here. And you could use this on your test, people. Now, remember the other thing we learned in this unit, this was kind of like another part of this lesson, was that the sum of the angles inside a triangle is 180 degrees. So all of these little angles inside our triangle are always going to add up to 180 degrees. So if you take a look, like at 18, find the measure of the missing angle. So it tells us what 2 of them are, and it wants us to find the other one. So how we would do that is we're going to add up all of these to 180. So let's do that. If I have a triangle, right, and the 3 measurements are 30 plus 90 plus, I don't know what the other one is, so let's call it x, equals 180. All 3 of my angles are going to add up to 180. So now we just solve it. What's 30 plus 90? Well, that's 120 plus x equals 180. How would I get rid of a plus 120? Well, I would minus 120. X equals 60 degrees. Not too bad. So to find the missing angle, you just add them all up to 180. Okay? So I'd have 60 degrees. Now how could I check my work here? Well, 30 plus 60 plus 90, is that 180? It is. 30 plus 60 is 90. 90 plus 90 is 180. Okay, you can always check your work. What about this one? I would do x plus 78 plus 29. Let's do that one real quick. I would have x plus 78 plus 29. Remember, all of my interior angles in a triangle add up to 180. 78 plus 29, let's see what that is real quick. 107. X plus 107 equals 180. Subtract 107 from both sides. X equals 73 degrees, I believe. Okay. So my missing angle here would be 73 degrees. Cool. See, guys, this isn't too bad. Now here it would get a little bit trickier because we have to find the value of x, but we can still do this. Let's try this one. 65 plus 65 plus 56 plus x equals 180. Let's try it. So if I did this one, 65 plus 65 plus 56 plus x equals 180, still not a big deal. We would just combine these like terms. 65 plus 65 plus 56, let's see what that is. 65. See, even I need to use the calculator sometimes. 65 plus 65 plus 56 equals 186. Plus x equals 180. Subtract 186 from both sides. X would equal negative 6. Cool. See, guys, this isn't too bad. So x would equal negative 6. Okay? It kind of feels like part plus part equals a whole, if you remember that from before. Part plus part plus part equals a whole, which is 180 every time. Okay, same thing on this one. Alright, so 3.3 was dealing with the types of triangles, and then that all the interior angles of a triangle add up to 180. Okay, very last unit. Okay, we have a video for you. 3.4. So, the rule here is that the exterior angle equals the sum of the 2 remote interior angles. So let's talk about what that means. If you see here, there's a triangle. 30 and 110, those angles are within the triangle. They're in the triangle. They're a part of the triangle. But this little guy out here is just chilling outside by himself, outside of the triangle. So this guy would be called our exterior angle. Okay? We would set this guy equal to the sum, which means adding, of the two remote interior angles, so 30 and 110. We don't deal with this guy, this angle right here, because this is really close. We want the angles that are far away from this exterior angle. So 30 and 110 are far away from the question mark. So let's call the question mark x and see what we would get. Okay. If we had this, our exterior angle equals remote interior angle plus remote interior angle, right? The sum of those two. So the exterior angle would be x equals, let's remind ourselves of what the remote interior angles would be. 30 plus 110. So our remote interior angles were 30 and 110. So if you go back here, 30 and 110. Okay. So x equals 30 plus 110. 30 plus 110 is 140 degrees. Okay. So our missing angle, this exterior angle, would be 140 degrees. Okay. We just keep doing that rule over and over. Here, our exterior angle is still a question mark, so we would do x equals 105 plus 46. No big deal. Now here it gets a little bit different because our exterior angle, we know what it is, but no big deal. We would do 112 equals x plus 89 because those are our two remote interior angles. So let me show you what that would look like. If we had 112 equals x plus 89, we would just subtract 89 on both sides, and we would get 112 minus 89. Let me see what that would be. 112 minus 89 would be 23. So 23 would equal x. Not too bad. So either way, guys, you can do it. So our missing angle right here would be 23. Okay, same here. You would do 100 equals 55 plus x. That's just our rule over and over. The exterior angle equals the sum of the two remote interior angles. Now here it gets a little bit trickier because there's some variables. So let's talk about what this would look like. If I have our exterior angle, right? Our exterior angle, if you look at our picture, would be 11x minus 2. And then the sum of our remote interior angles would be 50 plus 6x plus 8. Okay? Now let's talk about what we would do here. Well, we have two like terms, 50 and 8. So I'd have 11x minus 2 equals 58 plus 6x. We still have x's on both sides. So we want to subtract by 6x on both sides or subtract by 11x. I like to subtract by 6x to keep things positive. 5x minus 2 equals 58. Add 2 on both sides. 5x equals 60. Divide by 5. And x would equal 12. Now, that's what it's asking us for. X equals 12. But I think some of you guys are like, ah, man, Mr. Colson, I get an answer, but then it's like, I don't know if that's right. I don't know how to check my work. Well, let me just show you real quick how you could check your work here. If this was my original equation, 11x minus 2 equals 50 plus 6x plus 8, what I could do is I could plug in 12 in for x to just check my work. So 11, instead of x, I could put what I got, 12. Minus 2 equals 50 plus 6. Plug in 12 plus 8. And then I would just see if it's right, if they equal each other. So 11 times 12 would be 11 times 12 would be 132 minus 2 equals 50. 6 times 12, put in your calculator, would be 72 plus 8. And then we're just going to see if they equal each other. So this side would equal 130. 50 plus 72 plus 8 would also equal 130. So I did it right. Okay, you can always check your work by plugging in x back into the equation. Okay, just a helpful hint. You can always be confident of your answer. So here, x would be 12. Now, very last example, people. Very last example. The biggest thing, the hardest thing on this whole test is going to be something like this. If we solve for x and then find the indicated angle. So let's talk about this problem. I'm going to write this out on my paper. We would find the measure KDE. So this is what our picture would look like. We have a triangle, and we have this extension, something like that. We have F, D, K, E. This is negative 3 plus 19x. This is 11x plus 3, and this is 50 degrees. So what we do as always is we would solve for x, right? We have to make our equation. This is our exterior angle, negative 3 plus 19x equals 11x plus 3 plus 50. Okay? Then we would start solving for x. So this is something we've already done, right? We would combine these like terms. 53, 11x plus 53, negative 3 plus 19x. Okay, we keep going. I prefer to subtract 11x on both sides instead of 19, but you don't have to do that. X equals 53. 8x would equal 56 when I bring that 3 over, when I add 3. Divide by 8 on both sides, and x equals 7. But guys, that's not your answer. So, if you were to put 7 in your Canvas quiz on the test today, be like, Mr. Colson, it's 7, I'm going to be like, that's not your answer. You need to plug it back into the angle, because what are we trying to find? We're trying to find the measure of KDE. It's not saying to find x. So what is the measure of KDE? Well, KDE is negative 3 plus 19x. So let's write that down. The measure of KDE equals negative 3 plus 19x. Well, we can't put that in as our answer. That's silly. But we do know what x is. X is 7. Okay, let's plug that in. X would be 7. So, what's 19 times 7? Well, that's 133. So, negative 3 plus 133 is 130 degrees. So, that would mean the measure of KDE equals 130 degrees. It is not 7. That's not your answer. That's just part of the steps to get to your answer. Okay? So that's like the hardest question on your test, is first finding x and then finding the measure of the angle, plugging in for x. Okay? So hopefully that helps you guys. Not too bad. Use your review, do multiple attempts, use the notes on the test, do what you got to do to succeed on this test. Good luck.